Hello and welcome to the 8th video for mathematics of grade 11. In this video, we are going to continue section 2 of chapter 7, which is about trigonometric functions. So if you remember in the previous video, we covered the graph of sine function, the graph of cosine function, and there I told you how to graph them by using the method of point plotting. Now, in this video, we are going to continue the study of our graphs by graphing f of x equals tangent of x. So the method that I'm going to use here to graph tangent of x is a little bit different from the approach that we had for sine and cosine function, because I'm going to use the fact that the function tangent function can be written as the combination of sine function and cosine function. So if you remember from trigonometric identities, we can write tangent of x. The graph, the function tangent of x can be written as sine x divided by cosine x. And as you see in the denominator of this function, you have a cosine function, which can be 0 from time to time, right? For some values of x, cosine of x is equal to 0. And therefore, this function is going to have vertical asymptotes from time to time. That's why those vertical asymptotes make the graph of this function a little bit more complicated than the graph of sine and cosine function. So we have to change the approach that we had before. We cannot just make do with the point plotting method. So I'm going to mix point plotting with different approaches that involves the limiting behavior of the function close to some certain points where cosine becomes 0. So now, when x is 0, so when we are here at the origin, when x is 0, sine of 0 is 0, and cosine of 0 is 1. So we'll have 0 over 1, which is equal to 0, right? So at 0, at x equals 0, tangent of x becomes 0, right? Because it is of the form 0 over 1, and that gives us 0. So at 0, the function goes through the origin, 0 and 0, and that's what you see over here. But as x approaches to pi over 2, so as this x value approaches to pi over 2, as x approaches to pi over 2, we will see that sine of x approaches to 1, because sine of pi half is 1. So the values of sine start to rise from 0 to 1 as x approaches to pi over 2. And on the other hand, cosine of x start to get closer and closer to 0. So the values of cosine start to decrease from 1 to 0, right? Because once we were at 0, cosine is 1, but when we approach to pi half, cosine starts to get closer and closer to the number 0. So as you see, the overall fraction here starts to become larger and larger and larger. So that's how we write tangent of x. So as all of these things happening when x tends to pi over 2. So tangent of x starts to approach to positive infinity. And that's kind of obvious because you see, the numerator of this fraction is a finite number, but the denominator of this fraction starts to get very small, right? Starts to get closer and closer to 0. So the whole fraction becomes very, very large. So as long as the numerator is a finite number and the denominator is getting closer and closer to 0, the whole fraction starts to increase without bound. And that's what you see over here in the graph. Look, as we approach to pi over 2, the graph of the tangent function rises without bound. And that's what this part of the graph tells us. All right, so now let me erase some part of this so to make room for other considerations. Now we're going to study this part of the graph. So we want to see the behavior of the tangent function as long as its x value is between 0 and negative pi half, and see what happens over there. So now this time we're approaching to negative pi half. So as x tends to negative pi half, as x tends to negative pi over 2, let's see what happens. So again, we are going there, we are approaching to negative pi half from 0. So sine of x again is 0, cosine is 1, but now sine x approaches to negative 1. So sine x approaches to negative 1. So remember, we are approaching to negative pi half. As x tends to negative pi half, sine of x starts to get closer and closer to negative 1. And that's kind of obvious by considering this the graph of sine function, which we had before. So remember, the graph of sine function is something like this. In one cycle, it goes like this. From 0, that's pi. And that's 2 pi. And right over here, it's pi half, which takes on the value of 1. But on the left side of the graph, it goes down like this, then comes up, and then continues. So at this point over here is negative pi half, which you see the function takes on the value of negative 1. So as x tends to negative pi half, the sine function decreases to negative 1. Okay, and that's what we had before. So sine x approaches to negative 1. Okay, now let me erase the graph here. Let's see what happens to the graph of cosine function. So I claim that as x tends to negative pi half, cosine of x approaches to 0 again. And again, that's obvious by just looking at the graph of cosine function. So the graph of cosine function starts from here, if you remember. On the left side, it's like this. So and this point over here is negative pi over 2. So as x tends to negative pi half, as x approaches to negative pi half, as you see, cosine function again decreases to 0 with positive signs, right? So cosine decreases to 0. So as x tends to negative pi half, sine x approaches to negative 1, and cosine of x approaches to 0. So now let's see what happens to the whole fraction. The numerator is a negative number, right? Because sine x is approaching to negative 1 with negative values. So the numerator is a finite number which has a negative value. But cosine x, those are positive numbers, but they are decreasing to 0, right? With positive signs. So and that means that the graph of tangent of x, so tangent of x approaches to negative infinity, right? The whole fraction becomes very large, but with negative signs. The numerator is a finite number, the denominator is getting smaller and smaller and smaller, so the whole fraction becomes very, very large, but with negative values. And that's what you see over here in the graph. Look, as you approach from 0 to negative pi half, the graph descends without bound. It goes down forever. And that's what we say about the vertical asymptotes. As you see over here, the graph has a vertical asymptote at pi over 2 and another vertical asymptote at negative pi over 2. You can go ahead and copy the same method, the same approach that I had here for the interval of negative pi half to pi half to other intervals, like from pi half to 3 pi over 2, from 3 pi over 2 to 5 pi over 2, and so on. Or on the left side, from negative pi half to negative 3 pi half, from negative 3 pi half to negative 5 pi half. And exactly the same pattern emerges on those intervals. And that's what we mean by a periodic function. Again, you see here, tangent function is a periodic function. This pattern, this shape of the graph, repeats itself on those intervals. Same thing happens here. So as you see, what's the period of this function? You remember, period is the length of one cycle. So if you take this cycle, you see that this starts from negative pi half to pi half. So what's the length? Pi half minus negative pi half, which is pi. And so that's the period of this function. Let's write it down. Period is pi. what is the domain of this function? As you see, domain is the variation of the graph on the x-axis. So if you compress these parts of the graph over the x-axis, you will see that it covers everything on the x-axis except for these values, for these numbers on the vertical asymptotes of the graph. So at pi half, negative pi half, 3 pi half, negative 3 pi half, 5 pi half, negative 5 pi half, 7 pi half, negative 7 pi half. Those are the numbers that are excluded from the domain of the function. So and those are the odd multiples of pi over 2, right? 3 is an odd number, 1 is an odd number, negative 1, negative 3, 5, negative 5, and so on. So any odd multiple of pi over 2 is excluded from the domain. And that's what we mean here. Domain is all the real numbers except the values that are as of the form 2k plus 1 times pi over 2. 2k plus 1 is an odd number for any k. So if k is an integer, 2k plus 1 is an odd number. So these numbers are excluded from the domain of the function. And what's the range of the function? Well, as you see, the range, even if you take one cycle, even if you take this cycle over here, it covers everything on the y-axis. So if you push every point on the graph on the y-axis, it covers everything from negative infinity to positive infinity. And that's the range of this function. And that's it. That will conclude for us the study of the graph of these trigonometric functions. And now we have some other concepts in trigonometry, which we will see them right over here. And maybe possibly we will see some examples. So the first thing that we have here is definition of the amplitude of the sine and cosine function. So what is amplitude? The amplitude of sine and cosine function is half the difference between maximum and minimum value of those functions. So let's see, what is that? And amplitude is always a positive number. So let's see here, I put the graph of sine function. So this is the graph of sine function. The maximum value of this sine function is at 1. So it happens at pi over 2. Pi over 2 is 1. And so all the other ones are, the maximum points will be 1. And the same thing happens as of the minimum points, which happens here in this example at 3 pi over 2, it's negative 1. Okay, so the graph, as you see, the range of this function is between negative 1 and 1, and those are the maximum and minimum values of this function. So what you see here is that amplitude is half the difference between maximum and minimum. So from negative 1 to 1 is like 2 units, right? And half of that is 1. So that's what we say, the amplitude of sine function is equal to 1. Amplitude is equal to, so the difference is 2, but we divide it by 2 because it says half the difference. So it's 2 over 2, which is 1. Here I gave you another example. This graph represents y equals 3 sine x. So everything here is multiplied by 3. So it's like you're stretching the graph along the vertical line. So this one, which we had over here, will be replaced by 3. So 1 goes to 3. Whenever sine x is, whenever x is pi half, sine of pi half is 1, and then 1 times 3 is 3. So at pi half, this function obtains the value of 3. And that same thing happens. On 3 pi over 2, sine x is negative 1, so multiply 3 by negative 1, you will get negative 3. So now in this case, the maximum is 3, and minimum is negative 3. So what is the amplitude? Amplitude equals, so what is the difference? From negative 3 to 3, we have 6 units. So we should divide 6 by 2, which is equal to 3. And that's the amplitude of this function. Let's see the next slide. All right, so here in this slide, I put the summary of whatever we had so far. So you see the graph of sine function, periodic with period of 2 pi. Its domain is all the real numbers, and its range is negative 1 to 1. So these are the important characteristics of sine function, and its amplitude is 1. It goes 1 unit up. The maximum value is 1, and the minimum value is negative 1, and the half of that difference will be just 1. You see the graph of cosine function. again, this function is periodic with period of 2 pi. Its domain is all the real numbers, and its range is -1 to 1, and its amplitude is again 1, because the cosine function is just like sine function. It attains its maximum at 1 and its minimum at -1. This is the graph of tangent function that we just saw in the previous slides. It has vertical asymptotes at odd multiples of pi half. So those numbers are excluded from the domain of the function. So these are the odd multiples of pi over 2. Range is R, all the real numbers. It covers everything on the y-axis. And its amplitude is undefined because it doesn't attain maximum or minimum. Tangent doesn't have maximum or minimum. So that's why we say that it doesn't have any amplitude. So these are the important information that you need to remember from trig functions. The graphs of those functions, the domains and range of those functions, and periods and amplitude of those functions. Next thing we have here is we are trying to find amplitude and period of transformations of these trig functions. So what we saw before for the graphs of those trig functions, they were basic fundamental trig functions. Y equals sine x, y equals cosine x, y equals tangent of x. So we didn't have any numbers multiplied or added to those functions. There were no transformations back there. But what if we have transformations? What if a number is multiplied by sine function? What if x is multiplied by a number, and so on? So here are the formulas for period and amplitude of transformations of functions. So as you see over here, the graph y equals a sine bx. So a is a number, b is a number multiplied by x. The amplitude of this function is just absolute value of that number a. Even we had an example just like this one before in the previous slides right here. Y equals 3 sine x, and that 3 turned out to be the amplitude of the function. So the same behavior is happening in this slide here. So a will be the amplitude of the function. Just remember, it must be absolute value of that, because the amplitude is always positive number. And if x is multiplied by b, so that means you are stretching the function along the horizontal axis. So depending on b, if it's more than 1 or less than 1, between 0 and 1, whatever, this function is stretched. So this number stretches horizontally, this number stretches vertically. Sometimes, depending on the value of b, it stretches, it compresses or stretches, and it depends on the values of b. So whatever that b number is, the period of this function turns out to be 2 pi divided by the absolute value of b. Same thing happens for cosine function, 2 pi divided by absolute value of b. And as of tangent of bx, so no matter what number you have here, there's no amplitude, because there's no maximum or minimum for this function. But the period of this function is turned out to be pi divided by absolute value of b. So those are the formulas for period of these, the transformation of these trig functions. Let's see one example for this. Find the period and amplitude of the function f of x equals 5 sine 3x. So you can say right away that amplitude is, well, 5, the number which is over here. And what is period? So you have to use this formula, 2 pi divided by absolute value of 3. So period equals 2 pi divided by 3. And that's the period of this function.